Hello everyone, in this video I'm going to go over the log models using the wage dataset. So I have prepared the first part of a do file, which is, you already know, it's very important to study your data before you start. So you know how many observations, the mean, the standard deviation, the minimum and the maximum of each variable and so on. And also the description, the type of variable you have and so on. So we're going to do 4 types of models. So the first one is going to be the linear model. The second one would be the linear log model. Third, we're going to do log linear. And the last, log. Okay, so let me start here because it's easier to get the variables. So our dependent variable is wage. Let's have education, experience, non-white, joining a union, and gender. Okay, so suppose we have this model and we use a robust standard error. Okay, and we get the first linear model. I prefer to start from the command here because instead, like, just want to make sure that I'm writing the variables exactly as they appear. So it's easier to click on them than typing them, and then I would go here and just paste the regression. Okay, so you would have the linear model, and you have for the log, linear log, we have to create the log of one of the regressors. So let's start with education. Let's choose education. So generate L education equal log education. And of course, as I mentioned before, anything here after the generate command, you call it anything you like. You can call it your name. But I always, with log models, I prefer to type L before the variable. I want to also mention that you can also do, instead of log, you can type lin. It also give you the same result. So when you type log in Stata, would give you the same result as a natural log, which is lin. If you want the one with base 10, then you would type log 10. But in our course, I'm going to be using the natural log, so you can type either lin or log. I'm going to write log. Okay, and then so we have here created the log of one of the regressors. I chose education, and in the log linear, I'm going to generate the log of the dependent variable, which is the log of wage. Okay, and we're going to take this regression here and just put L, and then again here, and put here L, and here for the log it's going to be L. Okay, so now we have our 4 types. You can go ahead and just run it, and then as we know already, we have here the linear model. If I ask you what is the effect of a 1-year education on wages, wages increases by about $1.37. In the linear log model, this coefficient, when I have a linear log, has to be multiplied times 1/100 if I'm asking you what's the effect of a 1% increase in education. So a 1%, so I need to take this coefficient, multiply it times 1, divide by 100, or simply multiply times 0.01. Here I have a log linear model, so the effect of 1 year increase in education increases wages by 0.0998703 multiplied times 100. So you need to multiply this coefficient times 100 and add the percentage symbol. For the log model, it's the easiest because a 1% increase in education is equal to about 0.82% increase in wages. Okay, so this is the easy because you don't actually need to do anything with the coefficient itself. As you can see it here, you're just gonna write it. So when you do your when you type your do file, it's nicer to have everything clear. Okay, so it would be nice that you come under each regression and you extract the coefficient. So in your assignments or in your exams, I would be looking for coefficient extracted, not just writing from the output you see. So you better extract your coefficients, and to extract it, you basically use the command scalar. Call the coefficient any name you like. I call it beta underscore education. You call it anything, you can call it your name, but just I try to call all my coefficients as beta and then equal underscore b. So b is the matrix of coefficients in Stata, stored in Stata, and then you have to use the square bracket and the name of the variable you want to extract its coefficient. Okay, so here I extracted the coefficient of education. So when you run this part, it would take the coefficient of the variable of the regression right before it. So in order to do that, you basically click on the regression itself, and then the scalar would be created from the regression that precedes it. You can also do the same with the rest. So here, copy, paste, but just make sure that you're going to change the name. It's not like here I already created a variable called beta education. Maybe I would call it here 1. And remember, the variable here is L education, so you need to change this one to L. I'm gonna repeat the same thing here. I'm gonna call this one 2, and the variable education would come from the linear form of education, so this one is fine. And then the last one, I'm gonna call this one 3, and this one is L education. Okay, so now I have the coefficient of education extracted from each model. It would be also nice to display. So you would write display command, and what do you like to display? An additional year of education is associated with, and you close this quotation, is associated with a certain beta, which is this one. And then you continue the sentence. Dollars increase in wages or in wage rate, because it's per hour. Okay, so you have a statement, or you have a sentence, or you have a comment that is also going to be copied in your to be like displayed in your log file. So you can just copy it and repeat here. Now I have a linear log model, so education is in percent. So an additional, or you can call a 1% increase in education is associated with, this one is beta education 1, right? Dollars, because it's a linear log, dollars increase in wage rate. So a 1% increase in the years of education, or a 1% increase in years of schooling, it's nicer. in years of schooling. Like, it doesn't matter, but just like, I think it's better sentence, in years of schooling. 1% increase in years of schooling is associated with beta education $1 increase in wage rate. Okay, next. So the next one I'm going to again paste. Remember, this is a log linear model. So a log linear model, this one is in additional year of education or schooling. Doesn't matter. So since I said schooling, let me just change it. Schooling is just a representation of the results. Doesn't matter. Schooling, an additional year of schooling. Again, this is a personal preference. Okay, an additional year of schooling. Remember that it's going to be a percentage in the log. Okay, so this one is going to be 2, and this one is percent increase in wage rate. One thing that I forgot here. So remember, in a linear log model, we need to transfer this coefficient. So this coefficient is going to be multiplied times 1/100 or multiplied times 0.01. Okay, it's a 1%. So you either say 1/100 or multiply times 0.01. And then when I have a log linear model, my coefficient needs to be multiplied times 100, and I have to add the percentage symbol. Okay. Next, it's a log-log model. So the log-log model, let's take this statement right here, and we're going to display here, and then again, it's a 1% increase in schooling because it's a log-log model. So we're going to 1% increase in years of schooling associated with nothing, right? We're not going to do anything in this coefficient, but just remember it's 3. Beta education, 3% increase in wage rate. So that's it basically. So once you run this file, you would be able to get all the results displayed in the log file. Let me just make sure, like, you review all the comments and making sure that you didn't make any mistake. So this is beta coefficient, and it's taking the coefficient of this variable, right? And this is the variable that you're calling, or this is the coefficient that you're calling again. This is a linear model, so it's year and dollar. Linear log, so we created a log in one of the x's. I chose education. Of course, all the x's can be also log, but just I chose one of them. So I chose education. I created this variable. I have it right here. I generated its beta. Actually, if you just type beta education again without the 1, it would also be fine, but as long as it is not a generate command. But just I want to make it different from this one, so I added 1, and then it's taking the coefficient of the variable in the regression right before it. So here I have log education, so make sure you have the L right here, and then display a 1% increase. So it's a linear log, so the x is in percent, but the y is in dollars. So the coefficient has to be multiplied times 0.01. And remember, if what's the difference, if I want to ask you what's the effect of, I think you know this already, 16% increase in years of schooling. So in this case, you just go here, and this needs to be multiplied times 16/100 or 0.16. Okay, next, log linear model. So my dependent variable is in log, the x is in linear. I generated a new coefficient that is taken from the regression right before it, and then I'm displaying the results such that the x is linear, but y is in log, is in percent. So I need to take the coefficient and multiply it times 100. So an additional year of schooling is associated with beta education times 100. What if an additional 5 years of schooling, additional 5 years of schooling, then you just need to multiply this thing by 5 times 100 and add the percentage symbol. Okay. Next, log model. So log wage and log education. We created another coefficient called beta education 3. We're calling it back here. A 1% increase in schooling is associated with the coefficient without any transformation, percent increase in wage. What if I'm saying, or I'm asking you, what about a 3%? Okay, a 3% increase in years of schooling is associated with times 3. Okay, so that's it. So it's kind of straightforward. So all what you need to do right after you're done is just to run. Okay, let me just look close first. Is just to run your do file and go and get it from your path, right? So my path is here, is right here, and then it's here. Okay, so I do have all the results displayed. This is the nicest part because you just get your answers. A 16% increase in years associated with this. Of course, I need to have more spaces here. So I'm just going to go back and just add more spaces. And then a 1% increase in years of schooling is associated with the coefficient multiplied times divided by 0.01. So they basically take this coefficient and divided by 0.01 increase in wage rate. Okay, the same thing, you have the answers. An additional year of schooling is associated with, again, I'm going to add more spaces here, and the answers are all displayed in your log file. So I'm just going to go back here and just add more spaces just to make it look nicer. Okay, so that's it. If you have any question, please post on the discussion forum. The log models are kind of challenging, but with enough practice, you should be fine. Okay, so I'm gonna just close this one and exit. Okay, all right, so let me know if you have any questions.